it's super interesting right now. You have a formula, then you build it, then you like measure it again, and then you're like, oh, it's behaving different than I thought. And this whole loop is like test and failure right now in the industry. And it costs money, it costs time, and then imagine you need to scale it up. So what I'm doing, looking at like this, working with some colleagues at MIT and Air Force Lab, who found a different way how to measure and like the qubit and how to make better qubits and know upfront how the qubit behaves.
Welcome to The Institutional Edge, a weekly podcast in partnership with Pensions and Investments. I'm your host, Angelo Calvello. In each 30-minute episode, I interview asset owners, the investment professionals deploying capital, who share insights on carefully curated topics. Occasionally, we feature brilliant minds from outside of our industry driving the conversation forward. No fluff, no vendor pitches, no disguised marketing. Our goal is to challenge conventional thinking, elevate the conversation, and help you make smarter investment decisions, but always with a little edginess along the way. Welcome back to another episode of The Institutional Edge. We're going to jump back into part 2 of my conversation with Betina Kitzler, an MIT Sloan Fellow and an all-around AI nerd. Last time we discussed how 2026 is a year of reckoning for AI, and that AI, especially LLMs and GenAI, are going to need to show an ROI. In this episode, we're diving into AGI and quantum computing. Are we actually getting closer, or is this still science fiction? Because on one side, you got people like Denis Hassabis committed to developing AI, and then on the other hand, you got people like Jan LeCun remaining very skeptical. Are we getting closer, or is it science fiction? And I know, Betina, you're going to answer it any way you want, so go ahead. It's the existential question, you know. My PhD is in existential philosophy. You got to give me some credit for an existential question.
Also, in 5 years, are like, oh, I knew better. Like, predictions in AI is just like, it's very difficult. But you know what's interesting? It's like what we see right now, especially at experts like CEO of Google DeepMind, but also like the former AI researcher at Meta. He's like, it's totally nonsense to talk about artificial general intelligence, because right now the technology is about reading text and copying the pattern of a text. So here Argus also like, it's artificial intelligence, general intelligence, you can't learn from just text.
Right.
But then on the other side, it gets better the more compute power you put in. So it's like Meta, like you can like look at it and it gets better. It's actually, they calculate the length of the task an LLM can do right now to track when or if AGI is happening. And right now it's doubling every 7 months, I think. So there's progress. So it's very difficult to really say yes or no. But from our perspective, it's just math. Like right now, how should that happen? I don't know. And a lot of like experts say like it's nonsense. But in specific tasks, I totally believe like we're getting to a space where we think it's AGI. But I mean, what's intelligence itself? Like there is no common ground on what's intelligence and how to measure it, even for humans. We don't have a definition of it. So how can we talk about AGI? That's like, I'm always like curious about it.
Okay, but I'm going to go back. You mentioned something a second ago where we're finding that certain types of AI get very good at certain tasks. We saw this like in 2017 with ImageNet, right? When the deep neural nets were able to identify cat or not cat better than humans. Yes. I would consider that to be a superhuman, result. They achieved a superhuman result, but it's not generalizable.
Yeah.
AGI needs to be something that is generalized, and it could walk into, I don't know, a museum, and it'll talk to you about a painting, and then it'll talk to you about a restaurant that you go. I mean, you know what I mean? And those are trivial examples. But it's the idea that it has to be beyond a specific task for me.
Yeah,
That's how I would measure it. Can it be, can it generalize?
exactly. It's like what I really like, they compare with the coffee test, you know? Do you know the
I'm sorry,
coffee
the
test?
coffee test?
Coffee test. I love coffee, so that's why I like this
I haven't
example.
had coffee in 60 years, so I don't even know what you're talking about. Go ahead.
Oh my God. So the one thing is about AGI is like, okay, when something can make me coffee, then we reach AGI. Like, I don't know who said it, but this is like one example, like a famous one. It's because if you need to put in coffee in there, what if something like spills or like some technical issues on the coffee machine like happens? Can the artificial general intelligence solve that? Like, can it make me coffee in the morning, whatever happened? So this is like one way to think about it. And you need this is like you need to know how to make coffee. You need to see, okay, something went wrong, what went wrong, and this whole thing. When we go into robotics, which is another topic. So this one, the coffee test. But then why are we talking about so much about AGI when, as you said, like there are models who can see patterns we can't see, like in healthcare.
Right.
There's so much potential. There's so much going on right now. This is amazing. So let's focus on that, invest on that, because then we see a clear value and outcome for that. So I would just like look and focus on that, then on theoretical, like what's AGI and define it. And
But isn't that example, if you're going to focus on one difficult problem and try to achieve results using some type of AI that are equal to or better than what humans can achieve, isn't that first AlphaFold, what DeepMind did with proteins? They were able to solve the problem better than humans have been able to do it, right?
yes.
Okay.
And for that, you would need to know the problem, right? Like there are some amazing scientists that are like, oh, we can do this and that. And then they came in touch with like this problem. They're like, oh, let's do and solve this problem. And they did. So how to put this kind of like industries, people together. So we actually work on specific programs that we see there is like, if we solve that, we have so much value. And that's where also like coming back to the ROI discussion from before. Um, what I've observed is that a lot of smaller models now, like companies focusing on smaller models, on solving specific problems, which like costs less energy consumption, better outcomes, success rates. So really defining the problem, like in terms of, I think Google just launched a translation large language model, which is like, why? But that's like one simple example, but it's like in healthcare and like in other areas, like in finance. So people are going like training models on specific finance data for better large language models or other AI, whatever. Like it depends really on the problem, but I think that's the way to go forward.
Is to focus on specific problems that will generate the ROI, which could be manifest either in terms of profitability or societal impact. If you could do something with AlphaFold that helps scientists and researchers discover cures, and I think this has already been an outcome from that. But my point, though, about AlphaFold is for DeepMind, it's a step on the way to AGI. Solving that problem is a step, just like AlphaZero was a step on the way, because the whole issue with reinforcement learning, and then the paper that Silver and others wrote about it, what is it? Attention is all you need. And so I guess you're saying, I think you're saying this, and you'll tell me I'm wrong, like always, but you're saying, let's apply the optimal type of AI system or systems to a specific problem so we can generate the ROI and it will have some societal benefits, ideally, like in medicine. And maybe we'll stumble our way to AGI eventually. Is that kind of a stumbling being my verb? You could change that, but you know what I mean?
I mean, if you look at deep tech or technology advancement, that's usually how it works. Like you work on specific problems, you work through it, you get better and better, and like go like to like your ideas or vision.
But what does deep tech mean to you? Don't just give me that word, because I don't know that one. Are you taking me to my second point, which is quantum? Is that where you're going with this? Are you going to quantum? Otherwise, define deep tech for me.
Now I have to, right? It's a bit like just like one point before, like just like in like AGI, where like I really like to work on like real problems, and so often that step by step to bring ROI and value, especially in like to the society. But I also understand that as a company or entrepreneur, you have to have visions and you have to have like a North Star, not only for your company, but also for investors, right? So I think there's just two different worlds. We are like right now, especially like in media, and we talk about AGI, that's very like jumping back and forward. And I think that's just something we need to have in mind, like what AI can do right now and where it brings ROI, and what's for investors and getting money. What's your business model? Do you need investors? Do you have other portfolio? Like Google has a lot of other like income. Like who is talking about AGI and who is not about talking AGI in like in which kind, what kind of like in which sense and like in which kind of language?
Okay, now tell me about quantum. I know nothing about it, but my good friend, I will say, in Milan, Dr. Elisabetta Basilico has been studying quantum, so I know she's going to listen to this and give us some comments. But what the heck is quantum computing? Because in investing, I'm always looking for an edge. And if quantum computing can give me an edge to allow me to make better, faster decisions, I'm all in. But I don't even know what it is. And that's never stopped me before, but so go ahead.
What's quantum? That's a big question. Like I talked with many quantum, like with quantum physics, quantum investors. And what I've observed is that, and like my learning is, it's still in a research phase, right? It's totally research phase. We think about applications, but we're not there yet. Because if you look at, because it's very difficult to understand, even like quantum experts say it's like difficult to like explain it. And one thing that I always tell people when you want to know about more about quantum is like in our everyday life, if you have a ball, you throw it in a specific speed, you know where it lands, right? Like you can predict it, you can like calculate it. With tiny particles, they have different rules of nature. Like it's a totally different thing. They're not predictable. So now they think with this kind of ideas, you can manufacture new compute, like a new quantum computing, using this kind of like ideas, which it's not ideas anymore. It's like it's proven, but how to use that in calculating things you can't do with a classic computer. And quantum will never replace classic computers. It's only for specific tasks and specific problems that mirror match this kind of like particles behavior. So that's what I'm trying to like. What did you understand? Like,
so tell me about the specific tasks or problems that quantum is or will be well suited for. And you know, you gave the prefatory remarks. We're not there yet. We're in the research stage, but there's a lot of money flowing into this on the VC side. There's no question about that. So
especially now, yeah.
Right. So what are the tasks or problems that you envision it being well suited for?
I mean, what I've heard from the industry is like, especially in healthcare, molecules who are like, especially for drug discovery, they behave differently than we know from other like bigger particles, which means classic computers they're limited. So if those molecules behave differently and those many particles from quantum physics have this similar like rules of nature, then we can use, or we need to use quantum computing to solve like new products and new like discoveries in drugs. So this is like this kind of mirror, like in material science, you have this kind of like problem, or like, I don't want to say problem, it's kind of different, where objects behave differently than we see in our everyday life, like big objects, like a ball. It's like whenever I talk to scientists, they want to explain it to me. I'm like having so many more questions after I talk to them. So like for me, what I'm looking at right now is like, what's the industry? Where is the industry? Like right now, there's a research phase, but there are a lot of breakthroughs. There are different bets. What kind of like, it's kind of like qubits. Like what's the standards of quantum qubits right now? Like it's kind of part of the hardware. There is no standards. There are different bets. Microsoft is doing something different than IBM, than Google. But what you can see already in the industry is that companies buying each other, startups buying each other, like they're trying to evolve into a new phase where you need to bring also some use cases and like really prove that kind of like ideas you have from research paper, bringing it into like the application, the real world phase, and how to scale it up at the end. So right now you have different kind of hardware which you can't scale up. So it's like you do like little experiments. It's like on an experiment level right now. But whenever you scale it up, there are more problems occur.
I mean, I'm trying to get to an understanding of what type of problems, because I mean, I went down this road because you're doing this simulation commercialization.
Yes.
And I assume that takes quantum into some kind of commercial ecosystem, right?
So what I'm doing what I'm like looking at is like, it's a simulation tool for the hardware. So it's like how to manufacture better hardware. It's on a very low stack. We don't talk about application that's here. Then you have like healthcare, material science. They say it's like areas. I'm here, like it's research, how to make better qubits and to predict how the qubit behaves. Because we don't know. Like it's super interesting right now. You have a formula, then you build it, then you like measure it again, and then you're like, oh, it's behaving different than I thought. And this whole loop is like test and failure right now in the industry. And it costs money, it costs time, and then imagine you need to scale it up. So what I'm doing, looking at like this, working with some colleagues at MIT and Air Force Lab, who found a different way how to measure and like the qubit and how to make better qubits and know upfront how the qubit behaves. And this is like a huge thing in terms of like simulation of qubit. But then the question is, can you simulate other things, not just qubits? Like, can you use this kind of theory, which is like from nuclear physics? Can you implement it like for finance or logistics, where, you know, like data is very messy, like real life is very messy. We don't know how to put it in like those AI models we talked about. So can we use this kind of like theory for nuclear physics, where they're used to having this kind of very unpredictable inputs and behavior, not only for manufacturing quantum qubits, but for like things that we need right now, like logistics or anywhere you have like messy data. So that's what I'm looking into right now.
Messy data and sounds like instability.
Yes.
You know, it's a very uncertain environment, using a term from reinforcement learning. What the hell's a qubit?
Yeah.
I mean, you're throwing it around like I know what I'm talking about. I have no idea.
In simple terms, to storage information, like a chip, which is not, but just like to make it very simple. And you need thousands to make quantum computing work.
Okay.
And it's just one hardware piece.
Who makes them?
IBM is a manufacturer, for example. There are some labs who are making it. So, but it's, as I said, different qubits. Microsoft is doing it, but it's like they're fluxonium, they're transmon, and they're like different kind of like, it's engineering combined with physics, and it's a whole thing. I'm not an expert on that. I'm not going into the science thing. I'm just like I'm trying to figure out, okay, so you can do that. How can we use it? Who needs it? Who has that problem? What does it mean for investors? What does it mean for the whole ecosystem in quantum computing? And with all of technology that we are looking at right now, especially I think Europe and US both are very looking into technology, how to use it in different kind of industry and applications. Because I think there's a lot of potential. It's just like we need to think more creative, how to implement it for different kind of problems. Like it's at the end, it's a simulation tool. It's like simulating something which is very noisy. It behaves very unpredictable. So where else do we have this problem?
Now I understand it.
You do?
Yeah, about this much. There is my friends will tell you, my whole career was like that. It's like the Rio Grande, we say, a mile wide and an inch deep. So
you just need a great team. Like everyone is an expert on something. I'm on the business side. So I'm trying to figure out and like connect people with different kind of problems, industries, and trying to see where is the value in it.
So we're going to close here because I've taken way too much time, especially because of the foot fault I had at the beginning. But in closing, again, we're talking about institutional investors, whether it's a sovereign wealth fund, a pension fund, etc. What's your outlook going back to 2026? How can these folks think about AI, not in terms of investing in AI stocks or anything like that, but integrating AI so they can make better decisions? That would be the ROI. What advice would you give them looking forward beyond the hype? Because, we don't want to talk about all the hype. They'll put that aside.
I would go to the operational level, getting people together, cross-functional, and working through with them where they see the potential, where the problems, but also where they see the potential, and work through like a new process, a workflow, making a sandbox again, like and protected like framework, how to test it and see what the learnings are. And then how to make it better from there, doing it again and again. And then you can see, okay, does it make sense? And does it actually bring a better prediction for the business model, for like whatever, like in terms of like investing decisions. So it's really going back to the operational level and working through strategically.
Cross-disciplinary is key.
Yes.
You can't just talk to IT and you can't just talk to the portfolio manager. It's got to be across, or otherwise it'll be siloed and there'll be data problems and everything else, right?
It doesn't make sense. That's the whole thing about GenAI, large language model. Now they understand different disciplines and you can like put data together, structured and unstructured data. Like that's the whole point of it.
That's where you get the power, when you can start using both structured and unstructured data.
Yes, because that's new.
Within a secure environment.
Within a secure environment, yes. Especially in that industry. Like you can't especially in that industry, like don't test something on the fly.
Well, I usually ask my guest one final question, but I don't think it works for you. And that's, what's the worst investment pitch you ever heard? I don't think that suits you, does it? I could give you another opportunity and you could ask me any question you want.
Okay, I will ask you a question.
Oh, boy. Okay.
If you think about AGI, which you mentioned before. Yep. If you think AGI happens in 1 year, what would you do differently now?
Wow. First, I don't think it'll happen in 1 year. But if it happens in the near term, I would probably go back to my roots at the academy and work on understanding if it's ethical or not. Is it responsible or not? And the topic we didn't talk about is embodiment. I'd want to see if the AGI was embodied, because I think you need to have embodied AI to hit AGI. Are you okay with that or not? Are you going to push back like always?
Why do you think so?
Why you need embodiment?
Yes.
Because intelligence is embodied in humans. And if we're going to see, I know it's an alien intelligence and it could be disembodied, but that's my framework. I told you in my notes, I did my dissertation on embodiment. So yeah. I'm kind of stuck there. So I would look for this AGI to be embodied. And you're seeing a lot of work in robotics. And to your point, if it's going to make you coffee in a seamless fashion, I assume it has to have some kind of embodiment. So it knows how to put that little coffee thing that you all drink in Europe, that Keurig, in the little container and close it. So,
I mean, it's an interesting question because,
you disagree with me. As soon as you say that, I can see you don't like the answer. So don't tell me it's interesting. Just tell me.
I'm just observing like there's two things. Like one is like humanized AI, AGI, but also AI. Like you don't have to program chatbots to be like humans, right? You could have done it differently. And the other thing is like, how would AGI look like if you don't put it like in a robot who looks like a human? Like, why? And I have my opinion in that. I think in terms of like, in Asia, I think that's also they're more positive about AI. They feel like there is a soul in every object, right? So here, like in Western Europe, they're more like, oh, I don't know, I don't want to have a robot who like takes care of me when I'm older. I think if someone like, we still have this connection with like machines, kind of, you give names your car. So like there is this kind of sense, but I think it's worth talking about what's ethical, where is their like the line, and how we think about AGI or AI. Like let's say like only AI. It's already a question we really need to think about and making decisions, because like there's a lot of fear, and if you have a lot of fear, it defines regulations, it defines politics, it defines investments. And I think we need to be very careful how we use the language about it, and also like how AI looks in like human, or like humanize it or not humanize it. Like, yeah, that's why I just like thinking about. I don't have like a clear answer to that. I think it's just like worth like thinking through it.
I'm glad you don't have a clear answer, because to become dogmatic at this point in the development of AI would be a terminal matter. You have to stay open, because there's so many surprises. And I don't mean, open AI's ChatGPT. I mean AlphaFold, and even the stuff the folks did at DeepSeek. If what I read is true, and I've done a lot of reading and I've written on it, seems like they made some, how would I say, some strides in terms of efficiency. So to be dogmatic now is the worst thing. And then that dogmatism could either be optimistic dogmatism, or it could be pessimistic. So you have to be very careful.
Yeah.
So, Betina, we should probably write something one day, you and me, but I'm not going to write in German. German was one of my languages, by the way, at university.
Oh, wow. I didn't know that.
Yeah, nobody does. Trust me. I mean, with this accent, trying to speak German, I mean, I have a hard time saying sausage. So.
Okay, so next time we're writing in German. I think now we can do it.
Yeah.
We can practice.
No, not going to happen. I could use Google Translate.
That's the thing. I will never know. Or maybe I will. We can think, let's try. Let's test.
All right, I'm going to stop it here and say, Betina, thank you very much for playing along. I know it wasn't easy. We took a circuitous route, kind of like your career and my career. It's been all over, but thank you.
Thank you so much for having me. It's always a pleasure to talk to you, and I love your questions.
Well, thank you.
Really make me think a lot.
Well, that's why we should write something.
Yeah.
Thanks for listening. Be sure to visit P&I's website for outstanding content and to hear previous episodes of the show. You can also find us on P&I's YouTube channel. Links are in the show notes. If you have any questions or comments on the episode or have suggestions for future topics and guests, we'd love to hear from you. My contact information is also in the show notes. And if you haven't already done so, we'd really appreciate an honest review on iTunes. These reviews help us make sure we're delivering the content you need to be successful. To hear more insightful interviews with allocators, be sure to subscribe to the show on the podcast app of your choice. Finally, a special thanks to the Northrop family for providing us with music from the Super Trio. We'll see you next time. Namaste.
The information presented in this podcast is for educational and informational purposes only. The host, guests, and their affiliated organizations are not providing investment, legal, tax, or financial advice. All opinions expressed by the host and guests are solely their own and should not be construed as investment recommendations or advice. Investment strategies discussed may not be suitable for all investors, as individual circumstances vary.